January 18, 1943, near the village of Sinyavino, southeast of Leningrad. Colonel Mikhail Baryatinsky of the Soviet 502nd Tank Battalion is inspecting the frozen battlefield when his scouts report something extraordinary. A massive German tank sitting abandoned in a ravine, its huge bulk partially hidden by snow and camouflage netting. The tank is unlike anything the Soviets have seen before, far larger than the Panzer IIIs and IVs that have been tearing through Soviet armor for 18 months, and as Baryatinsky moves closer through the trees, he realizes with a shock of recognition that this must be the legendary Tiger, the German super tank that Soviet intelligence has been hearing rumors about for months, but which nobody has yet captured intact. The Tiger is sitting at an angle in the ravine, its massive gun pointing uselessly at the sky. And there are no German bodies nearby, no signs of battle damage, no indication of why this fearsome machine has been abandoned. Baryatinsky orders his men to approach cautiously because the Germans sometimes booby-trap disabled vehicles. But when the scouts reach the Tiger and carefully inspect it, they find no explosives, no traps, and most remarkably, no significant combat damage. The tank appears to have simply broken down and been abandoned by its crew. This is the intelligence windfall of incalculable value, because while the Soviets have destroyed Tigers in battle and examined the wreckage, they have never captured one intact enough to properly study. And this massive machine sitting in the snow represents an opportunity to understand the most dangerous weapon in the German arsenal. Within hours, recovery teams arrive with heavy equipment to extract the Tiger from the ravine, and the operation takes 3 days because the tank weighs 56 tons, more than twice the weight of a Soviet T-34, and moving it through snow and rough terrain requires enormous effort. When they finally succeed in recovering the vehicle and transporting it to a secure facility, word spreads rapidly through Soviet military and scientific circles that an intact Tiger has been captured. And within a week, a team of the Soviet Union's best tank designers, engineers, and metallurgists has assembled at the Kubinka proving grounds outside Moscow to conduct the most thorough examination of enemy technology that the Soviets have ever attempted. What these engineers are about to discover will shock them, vindicate Soviet tank design philosophy, and help explain why Germany, despite producing what appears to be a superior weapon, is actually losing the war of armored warfare. The story of how this Tiger came to be abandoned in a ravine, how Soviet engineers systematically dismantled and tested it, and what they learned about German and Soviet approaches to tank design is a story about engineering philosophy, industrial strategy, and the fundamental question of whether sophisticated perfection or practical adequacy wins wars. The Soviet engineers expected to find a tank that was superior to their own in every measurable way, and in many respects they did. But they also discovered fatal flaws that explained why the Tiger, despite its fearsome reputation, was actually a strategic liability for Germany. Too expensive, too complex, too difficult to produce in quantity, and too unreliable to sustain the kind of mobile warfare that Germany needed to win. This is the story of what happened when Soviet engineers examined a captured Tiger tank and realized that Germany was losing, not despite having better weapons, but in some ways because of them. By January 1943, Soviet tank crews had been hearing terrifying rumors about a new German tank for several months, and these rumors always followed the same pattern: stories of an invincible monster that could destroy any Soviet tank from distances of 2 kilometers or more, that could shrug off direct hits from Soviet tank guns and anti-tank rifles, and that seemed immune to the weapons that had previously been effective against German armor. The first confirmed encounters with tigers had occurred in September 1942 near Leningrad, and the reports from Soviet tank commanders who survived these encounters were uniformly grim. The new German tank had armor so thick that Soviet 76-centimeter guns couldn't penetrate it from the front at any range, and its gun was so powerful that it could destroy a T-34 with a single shot from distances where Soviet tanks couldn't even effectively return fire. The psychological impact of these early Tiger encounters on Soviet tank crews was devastating because for the first time since the T-34 had entered service in 1940, Soviet tankers felt outmatched by German armor. The T-34 had been a revolutionary design when it appeared. Its sloped armor provided excellent protection, its wide tracks gave it superior mobility in mud and snow. Its 76mm gun could destroy any German tank in service at the time, and its diesel engine was more reliable than German gasoline engines, while being less likely to catch fire when hit. For nearly 2 years, the T-34 had given Soviet tank crews a qualitative advantage over German Panzer IIIs and IVs, and this advantage had been psychologically crucial in sustaining morale during the darkest days of the German invasion. But the Tiger changed the equation completely, and Soviet tankers began reporting that their 76mm shells were simply bouncing off Tiger armor even at point-blank range, while Tigers could destroy T-34s from distances of 2 kilometers, far beyond the effective range of Soviet guns. Soviet intelligence had been trying desperately to learn more about the Tiger ever since the first encounters, and what they had managed to piece together from interrogations of captured German tank crews, examination of destroyed Tiger components, and espionage reports was both impressive and terrifying. The Tiger mounted an 80mm gun, the same weapon that had proven devastatingly effective as an anti-aircraft gun and anti-tank gun throughout the North African and Eastern Front campaigns. And this gun could penetrate 100mm of armor at 1 kilometer, which meant it could destroy any Soviet tank in service from distances where Soviet tanks couldn't fight back. The Tiger's frontal armor was reported to be 100mm thick and vertical, which was twice as thick as T-34 armor, and much thicker than any previous German tank, and additional armor plates could bring protection up to 120mm in critical areas. The tank weighed approximately 56 tons according to intelligence estimates, which meant it was nearly twice as heavy as a T-34 and required an engine of at least 600 horsepower to achieve even modest mobility. What Soviet intelligence didn't fully understand before capturing an intact Tiger was the full extent of the tank's complexity, the compromises that German engineers had made in its design, and the industrial and logistical challenges that came with fielding such a sophisticated weapon. The rumors and combat reports had painted a picture of an invincible superweapon, but the reality, as the Soviet engineers were about to discover, was far more nuanced and revealed fundamental differences in how German and Soviet designers approached the problem of creating an effective tank. The Germans had pursued excellence, a tank that would be superior in every measurable category of armor, firepower, and optics, while the Soviets had pursued adequacy at scale, creating a tank that was good enough in all categories while being simple enough to mass-produce and maintain under combat conditions. The captured Tiger would allow Soviet engineers to understand both the strengths and weaknesses of the German approach and to validate or question their own design philosophy. The Tiger that Soviet forces captured near Sinia-Vino in January 1943 belonged to the 502nd Heavy Panzer Battalion, one of the first Tiger units deployed to the Eastern Front, and understanding how this fearsome machine came to be abandoned requires understanding the context of the Leningrad siege and the brutal winter fighting that characterized operations in northern Russia. The 502nd Heavy Panzer Battalion had been committed to combat around Leningrad in September 1942, with a strength of about 20 Tigers, and initially the battalion achieved remarkable results. The Tigers' superior armor and firepower allowed them to dominate Soviet tank forces and provide crucial support for German defensive operations against Soviet attempts to break the siege. In the first weeks of operations, Tigers destroyed dozens of Soviet tanks while suffering minimal losses, and German commanders were enthusiastic about the new weapon's performance. But as autumn turned to winter and operations continued, problems began to emerge that highlighted the Tigers' vulnerabilities in the harsh conditions of the Eastern Front. The tank's enormous weight, 56 tons, made it prone to breaking through bridges that could easily support lighter German tanks, and many Russian roads and bridges were simply not engineered to handle such heavy vehicles, forcing Tiger units to take circuitous routes or wait for engineers to reinforce bridges before crossing. The Tiger's wide tracks, which were necessary to distribute its weight and prevent it from sinking into soft ground, were so wide that they exceeded the loading gauge for German railways, requiring the tracks to be removed and replaced with narrower transport tracks every time Tigers needed to be moved by rail, a time-consuming process that reduced operational flexibility. The tank's complex engine and transmission required more maintenance than lighter German tanks, and in the freezing conditions around Leningrad, mechanical failures became increasingly common as temperatures dropped below -30 degrees Celsius. The specific Tiger that the Soviets captured had been involved in defensive operations southeast of Leningrad when it suffered a catastrophic transmission failure while attempting to maneuver in broken terrain. German tank crews later interviewed by Soviet intelligence reported that Tigers were particularly vulnerable to transmission problems when operated by inexperienced drivers or when forced to make sharp turns under power, and the sophisticated Maybach transmission used in the Tiger was both powerful and fragile, capable of handling the tank's enormous weight under ideal conditions, but prone to failure when stressed. When this particular Tiger's transmission failed completely, the tank lost all ability to move under its own power, and the crew found themselves with a 56-ton immobile pillbox in a forward position that was rapidly becoming untenable as Soviet forces prepared a local counterattack. German doctrine in such situations was clear. If a disabled tank couldn't be recovered within a reasonable time, it should be destroyed to prevent capture, and demolition charges were carried for exactly this purpose. But the crew of this Tiger faced a difficult decision because while the transmission was broken, the engine still functioned, the gun was operational, and theoretically, the tank could be recovered if a heavy recovery vehicle could reach it. The crew radioed for recovery assistance, but the nearest recovery vehicle capable of towing a 56-ton tank was more than 20 kilometers away and would take hours to arrive. And as Soviet artillery began ranging in on their position and Soviet infantry was reported approaching, the crew made the fateful decision to abandon the tank without destroying it, possibly hoping that German forces would recover it later, possibly simply panicking under pressure, or possibly believing that the Soviets lacked the equipment to recover such a heavy vehicle, and that it would be easier to destroy it later rather than risk their lives attempting demolition under fire. Whatever the crew's reasoning, they abandoned an intact Tiger, and within hours Soviet scouts had discovered it, recognized its value, and called for recovery teams. The Soviet decision to commit substantial resources to recovering this disabled tank resources that included heavy tractors, engineering equipment, and 3 days of effort by recovery crews working in dangerous proximity to German positions, reflected how valuable Soviet commanders considered the opportunity to examine an intact Tiger. Previous Soviet attempts to study Tigers had been frustrated by the fact that Tigers destroyed in combat were usually burned-out wrecks with critical components destroyed or damaged beyond analysis, and examining wreckage could reveal only limited information about armor thickness and general layout, but nothing about how the tank actually functioned when operational. An intact Tiger with a broken transmission but otherwise functional systems represented an intelligence windfall that could answer questions Soviet engineers had been asking for months. When the captured Tiger arrived at the Kubinka proving grounds in late January 1943, the team of Soviet engineers, designers, and military officers who had assembled to examine it represented the cream of Soviet tank expertise. The team included designers from several tank design bureaus who had worked on the T-34 and other Soviet armored vehicles, metallurgists from Soviet steel research institutes, military officers with combat experience against Tigers, and representatives from Soviet intelligence agencies who wanted to understand German industrial capabilities. The examination they were about to conduct would be methodical, comprehensive, and would ultimately take several weeks as engineers systematically measured, tested, photographed, and analyzed every aspect of the Tiger's design. The first impression that the Tiger made on Soviet engineers was one of overwhelming massiveness. The tank was physically enormous compared to any Soviet armored vehicle, and its sheer bulk was intimidating even when stationary and silent. The Tiger measured 6.3 meters long, excluding the gun, which added another 2.5 meters, 3.7 meters wide with combat tracks, and 3 meters tall, making it significantly larger than the T-34, which measured only 5.9 meters long, 3 meters wide, and 2.4 meters tall. The weight difference was even more striking. 56 tons for the Tiger compared to 26.5 tons for the T-34, meaning that the Tiger was more than twice as heavy as the Soviet tank that had been considered a medium tank with good protection. This enormous weight was distributed across wider tracks, 725 millimeters for the Tiger compared to 500 millimeters for the T-34, but the ground pressure was still higher than the T-34's, because the weight increase more than offset the track width advantage. When Soviet engineers climbed onto the Tiger and opened the hatches to examine the interior, they found a level of spaciousness and crew comfort that was almost luxurious by Soviet standards. The Tiger's fighting compartment was roomy enough for the 5-man crew to work without constantly bumping into each other. The commander had an excellent cupola with all-around vision and protected periscopes. The gunner had sophisticated optics with excellent magnification, and the loader had easy access to ammunition stored in racks that were designed for quick reloading. The driver and radio operator Tsar machine gunner in the forward hull had adequate space and good visibility, and the overall impression was of a tank designed with crew ergonomics as a priority, something that was definitely not a characteristic of Soviet tank design, where crews were often cramped into minimal spaces with limited visibility and uncomfortable working conditions. Soviet engineers noted that the Tiger's interior layout suggested that German designers expected their tanks to operate for extended periods with the same crew, and therefore invested in features that would reduce crew fatigue and improve combat effectiveness over long operations. The armor examination revealed exactly what Soviet intelligence had reported, but seeing it directly was still impressive. The Tiger's frontal hull armor was a 100 mm thick and nearly vertical. The turret front was also 100 mm thick, and the side armor was 80 mm thick, with the rear armor being somewhat thinner at 80 mm. Soviet metallurgists took samples of the armor for analysis and found that the steel was of excellent quality with good hardness and toughness characteristics, and the armor plates were joined by interlocking joints that provided additional strength compared to simple welded joints. The armor quality was significantly better than early war German tank armor, which suggested improvements in German metallurgy and manufacturing, but Soviet metallurgists noted with satisfaction that their own armor steel was of comparable quality. The difference in protection between Tiger and T-34 was primarily due to thickness rather than material quality. The 80mm KWK-36 gun was examined with particular interest because this weapon had already proven itself as one of the most effective anti-tank guns of the war, and mounting it in a fully rotating turret with excellent optics made it even more deadly. Soviet engineers measured the gun barrel length, 56 calibers, meaning 56 times the 88mm bore diameter, examined the recoil system, studied the breech mechanism, and tested the elevation and traverse systems. The gun could elevate from -8 degrees to +15 degrees, which gave it good flexibility for engaging targets at different ranges and elevations, and the turret traverse was powered by a hydraulic system that allowed smooth, precise aiming, a significant advantage over manually traversed turrets, where gunners had to physically crank the turret around and where fine adjustments were difficult. The gun's performance was well documented from combat reports. It could penetrate 100 mm of armor at 1,000 meters, which meant it could destroy any Allied tank at combat ranges, and its accuracy was excellent thanks to the sophisticated optics that provided 2.5x magnification for the gunner. The engine compartment revealed a Maybach HL 230 P45 12-cylinder gasoline engine producing 700 horsepower, and this powerful engine was necessary just to move the Tiger's 56-ton mass at acceptable speeds. Soviet engineers noted that despite the engine's substantial power output, the Tiger's power-to-weight ratio was only 12.5 horsepower per ton, significantly worse than the T-34's 19.5 horsepower per ton, which explained reports from Soviet tank crews that Tigers, while capable of reasonable road speeds, were slower to accelerate and less agile than lighter Soviet tanks. The engine was complex with overhead camshafts, sophisticated carburation, and tight tolerances, and Soviet engineers immediately recognized that this was an engine designed for performance and efficiency rather than for ease of manufacture or maintenance. The cooling system was elaborate with multiple radiators. The fuel system used high-octane gasoline rather than diesel, and the air filtration system was sophisticated but complex, all characteristics that would make the engine difficult to maintain under field conditions and vulnerable to failure if not properly serviced. But it was the transmission that revealed the most striking example of German engineering sophistication taken to an extreme that created as many problems as it solved. The Tiger used a Maybach Olvar transmission with 8 forward gears and 4 reverse gears, and the system was hydraulically assisted to make gear changes manageable, despite the enormous torque being transmitted. The transmission also incorporated a sophisticated steering system that used a dual-radius epicyclic design, allowing the Tiger to turn in a relatively tight radius by varying power to the tracks, a considerable engineering achievement that gave the Tiger better maneuverability than its size would suggest. Soviet engineers examined this transmission with a mixture of admiration and horror, because while the mechanical ingenuity was impressive, The complexity was staggering, with hundreds of precisely machined components that had to work together with tight tolerances, and the failure of any one of dozens of gears, bearings, or seals could disable the entire tank. After completing the initial examination and documentation of the Tiger's design, Soviet engineers faced a critical decision about how to proceed with testing, and they chose an approach that would prove highly revealing. Rather than simply conduct careful measurements and calculations, they decided to test the Tiger under the same brutal conditions that Soviet tanks had to endure on the Eastern Front. This decision reflected Soviet testing philosophy, which emphasized practical reliability under harsh conditions over theoretical performance under ideal circumstances, and it would expose the fundamental differences between German and Soviet approaches to military equipment design. The first tests were straightforward performance measurements: maximum speed on roads and cross-country, acceleration, turning radius, and fuel consumption. On roads in good condition, the Tiger could reach speeds of approximately 38 kilometers per hour, which was respectable for such a heavy vehicle, though not as fast as lighter tanks. And the acceleration was reasonable, though not impressive. The Tiger took noticeably longer than a T-34 to reach its maximum speed due to its poor power-to-weight ratio. Cross-country performance was more problematic because while the wide tracks prevented the Tiger from sinking into soft ground, the tank's enormous weight meant that it broke through ice on rivers and ponds that could safely support lighter tanks, and it struggled on steep slopes where its engine didn't have enough power reserve to maintain speed while climbing. Soviet engineers noted that the Tiger consumed fuel at an astonishing rate. The 540-liter fuel capacity gave the tank an operational range of only about 100 kilometers cross-country before refueling was required, and on roads the range extended to perhaps 190 kilometers under ideal conditions. This meant that Tiger units would require extensive logistical support, with fuel trucks constantly shuttling between storage areas and operational units, and any disruption to fuel supply would immediately ground Tigers even if they were mechanically functional. By comparison, the T-34 had an operational range of approximately 360 kilometers with its internal fuel plus external drums, and its diesel engine could run on a variety of fuel grades, including captured German diesel fuel or even crude oil in emergency situations, while the Tiger's sophisticated gasoline engine required high-octane fuel and would not run properly on lower-grade substitutes. The armor testing revealed both the strengths and limitations of the Tiger's protection, and Soviet engineers conducted live fire tests using various anti-tank weapons to determine exactly what could and couldn't penetrate Tiger armor at different ranges. The 76mm gun used on T-34 tanks could not penetrate Tiger frontal armor at any range with standard armor-piercing ammunition. The shells simply bounced off or shattered against the thick steel plate, but side and rear armor could be penetrated at ranges under 500 meters if Soviet tankers could maneuver to get flank shots. The Soviet 85mm anti-aircraft gun, which was being considered for adaptation as a tank gun, could penetrate Tiger frontal armor at ranges of approximately 1,000 meters with armor-piercing ammunition, suggesting that upgunning Soviet tanks to 85mm caliber would restore parity in firepower. Interestingly, Soviet engineers discovered that the Tiger's armor, while thick, was not sloped like T-34 armor, and calculations showed that sloping armor at 60 degrees from vertical, as was done on the T-34, provided equivalent protection to vertical armor that was approximately 60% thicker, meaning that the T-34's 45mm sloped armor was roughly equivalent to 80mm vertical armor in terms of protection against kinetic penetrators. The reliability testing exposed the Tiger's most serious flaw and validated Soviet concerns about German over-engineering. Soviet engineers operated the captured Tiger continuously for several days, simulating combat conditions with frequent starts, stops, direction changes, and cross-country movement, and within 80 kilometers of operation, less than 1 tank of fuel. The transmission developed problems with gear changes becoming difficult and the steering becoming sluggish. By 150 kilometers, the transmission had failed completely, and the tank couldn't move under its own power, even though the engine was still running. When Soviet engineers disassembled the transmission to examine the failure, they found that multiple gears had suffered from tooth breakage, bearings had worn excessively, and seals had failed, allowing hydraulic fluid to leak, and this cascade of failures had been initiated by a single gear that had cracked due to stress, demonstrating the transmission's vulnerability to component failures. Soviet engineers conducted additional tests on the engine by running it continuously at various power settings and monitoring oil pressure, cooling system performance, and fuel consumption. And while the Maybach engine performed well under steady-state conditions, it proved finicky when subjected to the kind of rapid throttle changes and variable loads that characterized combat operations. The sophisticated carburation system was particularly problematic because it was sensitive to fuel quality variations, and when Soviet engineers tried running the engine on Soviet aviation gasoline instead of German high-octane fuel, the engine developed severe knocking and lost power, a critical vulnerability because it meant that Tigers operating deep in Soviet territory couldn't simply refuel from captured Soviet fuel supplies, but required German fuel to be transported from supply bases. The maintenance examination revealed the full extent of the Tiger's logistical demands, and Soviet engineers cataloged every specialized tool, every maintenance procedure, and every component that required regular service. The Tiger required approximately 30 man-hours of maintenance for every 10 hours of operation, a maintenance burden that was roughly 3 times higher than that of a T-34. And many maintenance procedures required specialized tools that weren't part of standard tank unit equipment. The tracks had to be removed and replaced with narrower transport tracks whenever the Tiger was moved by rail, and this process took a trained crew approximately 4 hours to complete. The engine required oil changes every 500 kilometers. Air filters needed frequent cleaning due to the dust and dirt of Eastern Front conditions, and the transmission required skilled mechanics to properly diagnose and repair problems when they occurred. Soviet engineers calculated the man-hours required to manufacture a Tiger based on the complexity of components and the precision of machining required, and they estimated that a Tiger required approximately 300,000 man-hours to manufacture compared to approximately 3,000 man-hours for a T-34, a 100-fold difference in manufacturing complexity. This meant that German factories could produce approximately 1 Tiger for every 100 T-34s that Soviet factories could produce in the same time period with similar resources. And while 1 Tiger was certainly more than a match for 1 T-34 in direct combat, it was definitely not a match for 10 T-34s simultaneously engaging it from multiple angles, and certainly not a match for 100 T-34s deployed strategically across a theater of operations. As Soviet engineers completed their systematic examination and testing of the captured Tiger and compiled their findings into comprehensive reports, a profound realization began to emerge that would influence Soviet tank design philosophy for the remainder of the war and beyond. The Tiger was undeniably superior to the T-34 in nearly every measurable category of combat performance. It had better armor, a more powerful gun, superior optics, more comfortable crew accommodations, and greater prestige. But despite these advantages, the Tiger represented a strategic liability for Germany, rather than an asset, because its sophistication and complexity made it unsuitable for the kind of total war that the Eastern Front had become. The fundamental insight that Soviet engineers reached was that tank warfare in 1943 was no longer about individual tank versus tank duels, where the technically superior vehicle would inevitably win, but rather about industrial production capacity, logistical sustainability, operational reliability, and the ability to field overwhelming numbers of adequately performing tanks, rather than small numbers of exquisitely performing tanks. The Tiger exemplified what Soviet engineers began calling prestigious engineering, design that prioritized measurable performance specifications and technical sophistication over the practical requirements of mass production, field maintenance, and operational sustainability. German engineers had apparently asked themselves, how can we make the best tank possible? While Soviet engineers had asked, how can we make a tank that's good enough to win battles, simple enough to mass produce, and reliable enough to keep fighting? The armor comparison perfectly illustrated this philosophical difference. The Tiger's 100 mm of vertical frontal armor provided excellent protection and could defeat any Allied anti-tank weapon at normal combat ranges, but it required more steel, more sophisticated metallurgy to handle the thicker sections, more complex machining to shape the plates, and resulted in a tank that was too heavy to cross most bridges and consumed fuel at unsustainable rates. The T-34's 45 mm of sloped frontal armor provided nearly equivalent protection through the principle of sloping. Angling the armor at 60 degrees from vertical approximately doubled its effective thickness against kinetic penetrators, while using half as much steel and keeping the tank's weight manageable. A Tiger's frontal armor might stop a few more shots before being penetrated, but was that incremental improvement in protection worth the enormous increase in manufacturing complexity, weight, and logistical burden? Soviet engineers concluded that it was not. The gun comparison revealed similar issues. The Tiger's 88mm KWK-36 was unquestionably superior to the T-34's 76mm gun, capable of destroying any Allied tank at ranges exceeding 2 kilometers, while the 76mm struggled to penetrate Tiger armor even at point-blank range. But Soviet engineers noted that in actual combat conditions on the Eastern Front, engagements rarely occurred at ranges exceeding 1 kilometer because terrain, weather, and tactical situations usually prevented long-range shots, and at ranges under 1 kilometer, the T-34's gun was adequate for destroying German Panzer IIIs and IVs, while the Tiger's gun was devastating but not proportionally more effective. A target hit by either gun was equally destroyed. The real question was whether having a gun capable of 2-kilometer kills justified the Tiger's manufacturing complexity and operational limitations, especially when Soviet forces could respond to Tigers by developing an 85mm gun that would provide adequate penetration without the Tiger's disadvantages. The transmission represented the most egregious example of German over-engineering, creating more problems than it solved, and Soviet engineers were particularly critical of this aspect of Tiger design. The Maybach-Olvar transmission was a masterpiece of mechanical engineering with its 8 forward gears, hydraulically assisted gear changes, and sophisticated steering system, but it was also a catastrophically unreliable component that frequently failed under combat conditions and required specialized maintenance that field crews couldn't provide. Soviet engineers contrasted this with the T-34's simple 4-speed transmission, which was crude, required substantial physical effort from the driver to change gears, and didn't provide the Tiger's smooth gear transitions, but which almost never failed catastrophically, could be repaired in the field with basic tools, and didn't require specialized training to maintain. The T-34's transmission was objectively worse in terms of engineering sophistication and driver comfort, but it was operationally superior because it kept working under the harsh conditions of the Eastern Front, where the Tiger's sophisticated transmission consistently failed. The most damning calculation that Soviet engineers made was the production ratio. Based on their estimates of manufacturing complexity, a German factory using the resources to build one Tiger could instead build approximately 5 Panzer IVs or 10 simpler designs, while Soviet factories could build approximately 100 T-34s with the same resources. This meant that every Tiger Germany produced represented a choice not to produce 5 or 10 or 100 simpler tanks. And while the Tiger might be worth 5 Panzer IVs in direct combat, it was definitely not worth 100 T-34s deployed strategically across the front. The mathematics of industrial warfare favored mass production of adequate equipment over boutique production of excellent equipment, and the Tiger, despite its battlefield effectiveness, actually weakened Germany's overall armored strength, because the resources invested in Tigers couldn't be invested in producing the larger numbers of simpler tanks that Germany desperately needed. Soviet engineers also recognized that the Tiger's design philosophy reflected a fundamental misunderstanding of what the war had become by 1943, suggesting that German designers were still thinking in terms of pre-war concepts of armored warfare, where battles would be decided by the technical superiority of individual weapon systems. The German approach seemed to assume that if you built a tank with thick enough armor and a powerful enough gun, it would be invincible and could dominate any battlefield. But this assumption failed to account for several realities of modern warfare: that superior numbers could overwhelm technical superiority through concentration of force, that logistical limitations could render technically superior weapons inoperative, that manufacturing complexity limited production quantities, and that mechanical unreliability could neutralize combat effectiveness more effectively than enemy fire. The Soviet alternative philosophy, exemplified by the T-34, was based on achieving adequate performance in all categories while prioritizing manufacturability, maintainability, and reliability over maximum performance. The T-34's armor was good enough to provide reasonable protection against most German anti-tank weapons at normal combat ranges. Its gun was good enough to destroy most German tanks at those ranges. Its mobility was good enough to execute tactical maneuvers. And most importantly, it was simple enough to mass produce in factories throughout the Soviet Union, using workers with minimal specialized training, reliable enough to operate under harsh conditions with minimal maintenance, and easy enough to repair that field mechanics could keep tanks operational without specialized tools or expertise. Soviet engineers calculated that during the time it took German industry to produce one Tiger tank, Soviet factories produced approximately 100 T-34s, and even accounting for the Tiger's superior combat effectiveness in direct engagements, this production ratio meant that Germany was losing the quantitative race in armor. Even if each Tiger could destroy 10 T-34s before being disabled, an optimistic estimate, Soviet numerical superiority would still overwhelm German forces through sheer quantity, and more realistic combat loss ratios suggested that Tigers, while formidable, weren't destroying anywhere near enough Soviet tanks to offset their production disadvantage. The mathematical reality was brutal. Germany couldn't win an attritional armored warfare campaign against the Soviet Union because Soviet industrial capacity vastly exceeded German capacity, and by investing resources in sophisticated but production-limited Tigers rather than simpler but mass-producible tanks, Germany was actually accelerating its own defeat. The fuel consumption issue highlighted another critical flaw in the Tiger's design that stemmed from German assumptions about how armored warfare would be conducted. The Tiger's operational range of 100 kilometers cross-country meant that units equipped with Tigers required constant fuel resupply, and maintaining this resupply became increasingly difficult as German logistics deteriorated under Soviet pressure. Soviet engineers noted that the Maybach HL-230 engine, while powerful, consumed gasoline at approximately 540 liters per 100 kilometers under combat conditions, compared to the T-34's diesel consumption of approximately 180 liters per 100 kilometers, 3 times higher fuel consumption for roughly equivalent operational mobility. This meant that Tiger units required 3 times as much fuel infrastructure, 3 times as many fuel trucks, and 3 times as much vulnerable supply line capacity as T-34 units, and any disruption to German fuel logistics would immediately ground Tigers even if they were mechanically operational. Soviet engineers recognized that this vulnerability was particularly serious on the Eastern Front, where distances were vast, supply lines were long and vulnerable to partisan attack, and German logistics were already stretched to breaking point, trying to supply armies fighting hundreds of kilometers from German-controlled railheads. A T-34 could operate for several days without refueling if necessary, allowing Soviet commanders to execute deep penetrations and exploitation operations that cut German supply lines. But Tigers were tethered to their fuel supplies and couldn't range more than 50 kilometers from supply points before having to turn back or risk running out of fuel. This logistical limitation severely constrained how German commanders could employ Tigers tactically, forcing them into defensive roles or short-range offensive operations where fuel resupply could be maintained. The maintenance burden that Tigers imposed on German forces was another critical vulnerability that Soviet engineers identified as a strategic weakness. The examination had revealed that Tigers required approximately 30 man-hours of maintenance for every 10 hours of operation, and much of this maintenance required specialized tools and training that weren't available in field conditions. When Tigers broke down, and they broke down frequently due to transmission failures, engine problems, or track damage, they often had to be evacuated to rear area workshops for repairs rather than being fixed in the field. And this evacuation process was time-consuming, dangerous, and often resulted in Tigers being abandoned if they broke down in forward positions where recovery vehicles couldn't safely reach them. Soviet engineers contrasted this with T-34 maintenance, which was designed to be performed by minimally trained crews using basic tools, and even major repairs like engine replacement could be accomplished in field workshops using standardized components. The T-34's diesel engine was robust and forgiving of poor quality fuel, inadequate maintenance, and harsh operating conditions. And when T-34s did break down, they could usually be repaired and returned to service within hours rather than requiring evacuation to rear workshops. This meant that T-34 availability rates, the percentage of tanks that were operational at any given time, remained high even under intense combat conditions, while Tiger availability rates were chronically low due to mechanical failures, maintenance requirements, and the difficulty of conducting repairs under field conditions. The crew training requirements for Tigers versus T-34s represented another advantage for Soviet forces that stemmed from differences in design philosophy. Operating a Tiger effectively required months of specialized training. Drivers needed to learn how to manage the complex transmission and avoid the specific driving behaviors that could cause transmission failure. Gunners needed extensive training to exploit the sophisticated fire control system and advanced optics, and mechanics needed specialized instruction to maintain and repair the intricate systems. Soviet engineers estimated that training a competent Tiger crew required at least 6 months of intensive instruction, and this long training pipeline meant that replacing Tiger crews who were killed or wounded was time-consuming and created bottlenecks in unit effectiveness. By contrast, T-34 crews could be trained to basic competence in approximately 6 weeks, and while experienced crews were certainly more effective than raw recruits, the T-34's simpler systems meant that even minimally trained crews could operate the tank adequately. This allowed the Soviet Union to rapidly expand its armored forces by training new crews in batches, and when crews were lost in combat, they could be replaced relatively quickly without severely degrading unit effectiveness. The longer Tiger training pipeline meant that German heavy tank units couldn't easily absorb losses and maintain combat effectiveness, and as experienced Tiger crews were killed in combat, replacement crews were often inadequately trained and made tactical and mechanical mistakes that reduced the Tiger's battlefield effectiveness. Soviet engineers also analyzed the tactical implications of the Tiger's design characteristics and concluded that while the Tiger excelled in defensive operations where its superior armor and gun could be used from static positions to destroy approaching Soviet armor at long range, it was poorly suited for offensive operations that required mobility, reliability, and logistical sustainability. The Tiger's poor power-to-weight ratio meant that it couldn't keep pace with lighter German tanks during breakthrough operations. Its high fuel consumption limited how deep into enemy territory it could penetrate before requiring resupply, and its mechanical unreliability meant that Tigers frequently broke down during long-range offensive operations and had to be abandoned because recovery vehicles couldn't reach them or didn't have time to effect repairs before Soviet forces overran the area. This tactical limitation meant that Tigers were most effective when used as mobile fortifications, positioned in defensive positions where they could engage Soviet tanks at long range while remaining close to maintenance facilities and fuel supplies. But this defensive use didn't align with German strategic requirements in 1943 and beyond. Germany needed to conduct offensive operations to regain lost territory, to disrupt Soviet preparations for major offensives, and to maintain the initiative that had characterized German operations in 1941-1942, but the Tiger was fundamentally unsuited for the kind of mobile, long-range offensive warfare that these strategic requirements demanded. By producing Tigers instead of lighter, more mobile tanks that could have supported offensive operations more effectively, Germany was actually undermining its own strategic objectives while producing impressive but strategically limited weapons. The Soviet examination of the captured Tiger ultimately led to a series of design decisions that would shape Soviet armored warfare for the remainder of World War II and into the post-war period. Rather than attempting to match German technical sophistication by designing a Soviet super-heavy tank with extremely thick armor and a massive gun, Soviet designers decided to upgun the T-34 to 85mm in caliber while maintaining the basic chassis design, resulting in the T-34-85 that entered service in 1944. This approach gave Soviet forces a gun capable of penetrating Tiger frontal armor at reasonable combat ranges while preserving the T-34's advantages in manufacturability, reliability, and operational range. And the T-34-85 could be produced in massive quantities using existing production infrastructure with minimal retooling. Soviet designers also began work on the IS-2 heavy tank, which did mount a powerful 122mm gun and thick armor comparable to the Tigers, but Soviet designers learned from German mistakes by keeping the design as simple as possible, using proven components from existing Soviet tanks where feasible, and prioritizing reliability and manufacturability over maximum performance. The IS-2 was still a complex tank by Soviet standards, but it was far simpler than the Tiger and could be produced in much larger quantities while maintaining reasonable reliability under field conditions. Critically, Soviet heavy tank production was positioned as a supplement to T-34 production rather than a replacement for it, ensuring that the Soviet Union maintained numerical superiority through mass production of medium tanks, while having sufficient numbers of heavy tanks to counter German Tigers and Panthers in situations where their firepower was necessary. Soviet engineers' reports on the captured Tiger explicitly stated that Germany's decision to produce such sophisticated and complex tanks was a strategic error that the Soviet Union should not replicate, and these reports argued that the Tiger represented a technological dead end where pursuing maximum individual vehicle performance had been taken to an extreme that actually reduced overall combat effectiveness. The reports praised certain aspects of Tiger design, particularly the 88mm gun, the excellent optics, and the thick armor, but concluded that these advantages were overwhelmed by the tank's disadvantages in production complexity, operational reliability, logistical demands, and maintenance requirements. The fundamental conclusion was that Germany was losing the war of armored warfare, not despite having better individual tanks, but in significant part because of the design philosophy that prioritized individual excellence over collective adequacy at scale. The Soviet examination of the captured Tiger tank revealed insights that extended far beyond the specific technical characteristics of one German tank design, illuminating fundamental differences in how Germany and the Soviet Union approached the challenge of designing, producing, and deploying military equipment during total war. These differences in design philosophy reflected deeper cultural, industrial, and strategic assumptions that shaped how each nation conducted warfare. And understanding these differences helps explain why the Soviet Union ultimately prevailed in the titanic struggle on the Eastern Front, despite Germany's advantages in technology, military experience, and initial tactical success. German design philosophy, as exemplified by the Tiger, emphasized technical excellence and performance maximization within the framework of relatively small-scale production by highly skilled workers using precision manufacturing techniques. This approach reflected Germany's pre-war industrial structure, which was characterized by numerous medium-sized firms producing high-quality products in limited quantities for demanding customers who valued craftsmanship and technical sophistication. German engineers were trained to pursue optimal solutions to engineering problems, to minimize compromises, and to create products that would perform at the highest possible level, even if this required complex manufacturing processes and expensive materials. This philosophy worked well for producing luxury automobiles, precision machine tools, and sophisticated scientific instruments for peacetime markets. But it proved poorly suited for total war, where victory depended on producing adequate equipment in overwhelming quantities, rather than producing excellent equipment in limited quantities. Soviet design philosophy, by contrast, emphasized practical adequacy, manufacturing simplicity, and operational robustness within the framework of mass production, using workers with minimal specialized training and factories equipped with relatively crude machine tools. This approach reflected Soviet industrialization in the 1930s, when Stalin's regime had built massive factories designed to produce standardized products in enormous quantities, using simplified processes that didn't require highly skilled workers, because the Soviet Union lacked the large pool of craftsmen and precision manufacturing infrastructure that Germany possessed. Soviet engineers were trained to pursue good enough solutions that could be manufactured with available tools and materials, to accept compromises that simplified production even if they reduced performance, and to design products that could be maintained and repaired under harsh conditions by minimally trained personnel with basic tools. The difference in manufacturing approaches was starkly illustrated by comparing how Tigers and T-34s were produced. Tiger production took place in relatively small factories where skilled workers hand-fitted components, adjusted tolerances, and individually tested each system, resulting in tanks that were essentially custom-built, with significant variation between individual vehicles and requiring extensive quality control to ensure everything worked properly. This artisanal approach to manufacturing meant that Tiger production rates were limited by the availability of skilled workers, and increasing production would have required training more specialists, a time-consuming process that couldn't be accomplished quickly. T-34 production, by contrast, took place in massive factories where unskilled or semi-skilled workers assembled standardized components using simplified processes that required minimal adjustment or fitting, resulting in tanks that were essentially identical within manufacturing tolerances and required minimal quality control because the production process itself ensured basic functionality. This mass production approach meant that T-34 output could be rapidly increased by hiring more workers, building more production lines, and running existing lines for longer hours, all things that could be accomplished relatively quickly without requiring years to train specialized workers. The strategic implications of these different approaches became apparent when the war turned into an attritional struggle, where victory would be determined by which side could sustain higher losses while continuing to replace destroyed equipment and maintain offensive operations. Germany's sophisticated but limited production approach meant that every Tiger destroyed represented a significant loss that would take months to replace because the resources required to build a replacement. Tiger, skilled labor, specialized materials, precision manufacturing capacity, and time were in limited supply and couldn't be rapidly expanded. The Soviet mass production approach meant that every T-34 destroyed could be replaced within weeks because Soviet factories could simply run additional production shifts, hire more workers from the vast pool of available labor, and maintain output rates that far exceeded German capacity. Soviet engineers recognized that this production advantage was more valuable than any individual technical advantage the Tiger possessed, and their reports explicitly stated that the Soviet Union's ability to produce 10 or 20 or 100 T-34s for every Tiger that Germany produced was a strategic asset more important than having a small number of technically superior tanks. This insight reflected a broader understanding that modern industrial warfare was fundamentally about resource mobilization, production capacity, and logistical sustainability rather than about the technical characteristics of individual weapons, and that victory would go to the side that could most effectively translate industrial capacity into military power at the front. The reliability comparison between Tigers and T-34s illustrated another critical aspect of design philosophy: the Soviet emphasis on operational simplicity and field maintainability as design priorities equal in importance to combat performance. German engineers had designed the Tiger to maximize combat effectiveness with sophisticated systems that provided excellent performance when everything worked correctly. But these sophisticated systems were fragile and required constant maintenance by skilled technicians using specialized tools. When Tigers broke down, and they broke down frequently, they often couldn't be repaired in the field and had to be evacuated to rear workshops. And if they broke down in forward areas where recovery was impossible, they had to be abandoned and destroyed to prevent capture. Soviet engineers had designed the T-34 with the assumption that it would be operated under harsh conditions by minimally trained crews, maintained under field conditions by mechanics with basic tools, and that battlefield damage or mechanical failures would need to be repaired quickly without specialized equipment. The T-34's simple, robust systems reflected this design philosophy. The diesel engine was forgiving of poor maintenance and could run on low-quality fuel. The transmission was crude, but nearly indestructible. The suspension was simple, with large road wheels that were easy to replace, and most repairs could be accomplished in field workshops without specialized tools. This emphasis on field maintainability meant that T-34s could be kept operational under conditions that would have disabled Tigers, and Soviet units maintained higher operational readiness rates despite facing harsher conditions and having less sophisticated maintenance infrastructure than German units. The fuel consumption comparison revealed strategic vulnerabilities created by German design choices that prioritized performance over logistical sustainability. The Tiger's Maybach HL-230 gasoline engine was powerful and sophisticated, but it consumed fuel at 3 times the rate of the T-34's diesel engine, while providing only marginally better mobility due to the Tiger's poor power-to-weight ratio. This meant that Tiger operations required extensive logistical support with fuel trucks, forward fuel dumps, and protected supply routes, and any disruption to this logistical chain immediately rendered Tigers immobile, regardless of their combat capability. The Germans had essentially designed a tank that was vulnerable to logistical interdiction, and as Soviet forces learned to target German supply lines with partisan raids, air attacks, and deep penetrations by mobile forces, German armored units increasingly found themselves immobilized by fuel shortages rather than by combat losses. Soviet designers had deliberately chosen diesel engines for the T-34, despite diesel being technically inferior to gasoline in power-to-weight ratio, because diesel offered strategic advantages that outweighed the performance penalty. Diesel fuel was less volatile and less likely to cause catastrophic fires when tanks were hit. Diesel engines could operate on crude oil or other low-grade fuels if necessary, and diesel consumption was lower, allowing longer operational ranges. These advantages meant that T-34s could operate farther from their supply bases, could improvise fuel supply using captured stocks or locally sourced petroleum products, and were less vulnerable to supply disruption than German tanks. The strategic value of these operational characteristics exceeded the tactical value of the Tiger's superior armor and firepower in determining overall combat effectiveness across extended operations. The crew training requirements represented another aspect of design philosophy, where Soviet emphasis on simplicity provided strategic advantages despite tactical compromises. Training a competent Tiger crew required months of specialized instruction because the tank's sophisticated systems demanded skilled operators who understood how to extract maximum performance from the fire control system, how to avoid transmission damage through proper driving technique, and how to maintain the complex systems under field conditions. This long training pipeline created a bottleneck where German heavy tank battalions couldn't easily absorb casualties and maintain effectiveness, and as experienced Tiger crews were killed, replacement crews were often inadequately trained and made costly mistakes. T-34 crews could be trained to basic operational competence in weeks rather than months, because the tank's simple systems didn't require extensive specialized knowledge. And while experienced crews were certainly more effective than novices, the difference was less pronounced than with Tigers. This meant that Soviet armored units could rapidly absorb replacements, expand by forming new units, and maintain numerical superiority even while suffering high casualties. The strategic value of being able to rapidly train replacements and sustain operational tempo despite losses outweighed the tactical advantage of having more sophisticated but harder to operate tanks, because wars are won by sustained operations rather than by individual engagements, and sustained operations require the ability to replace losses faster than the enemy can inflict them. Soviet engineers' analysis of the captured Tiger ultimately concluded that German design philosophy represented a fundamental misunderstanding of what industrial warfare had become by 1943, with German engineers apparently still thinking in terms of quality over quantity, and assuming that technical superiority would translate into battlefield dominance. The reality was that industrial warfare rewarded mass production, logistical efficiency, operational reliability, and the ability to sustain high loss rates while maintaining offensive operations, and these attributes were better served by simple, adequate designs produced in overwhelming numbers than by sophisticated, excellent designs produced in limited quantities. The Tiger was a magnificent achievement of engineering that nonetheless represented a strategic failure, because it embodied design priorities that weren't aligned with the strategic requirements of winning a total war against an enemy with superior industrial capacity and vast reserves of manpower. The insights gained from examining the captured Tiger tank had immediate and long-lasting effects on Soviet tank design, production priorities, and tactical doctrine that shaped the remainder of World War II and influenced Soviet armored warfare philosophy well into the Cold War era. The most immediate impact was the accelerated development and production of the T-34-85, which mounted an 85-meter gun capable of penetrating Tiger armor at combat ranges while retaining the T-34 chassis design that had proven so successful since 1941. The decision to upgun the existing T-34 rather than designing an entirely new medium tank reflected Soviet designers' conclusion that the T-34's basic design was fundamentally sound, and that attempting to match German technical sophistication with a completely new design would be counterproductive. The T-34-85 entered production in early 1944 and combined the T-34's proven advantages in mobility, reliability, and manufacturability with significantly improved firepower that allowed Soviet tank crews to engage Tigers on more equal terms. The 80mm gun could penetrate a 100-meter of armor at 1,000 meters with armor-piercing ammunition, meaning that T-34-85s could destroy Tigers from ranges where the Tiger's armor advantage was negated. And while the Tiger still had superior armor protection, the T-34-85's mobility allowed Soviet crews to maneuver for flank shots where Tiger armor was vulnerable. Critically, the T-34-85 maintained the simple, robust characteristics that had made the original T-34 so successful while addressing the one significant deficiency inadequate firepower against heavy German armor that had emerged as Tiger and Panther tanks became more common on the battlefield. The production transition from T-34-76 to T-34-85 was accomplished with minimal disruption to output rates because Soviet designers had deliberately kept the modifications as simple as possible. The hull remained essentially unchanged. The engine and transmission were unchanged, the suspension was unchanged, and the main modifications were a larger turret to accommodate the 85-millimeter gun and its 3-man crew, adding a loader so the commander could focus on tactical command rather than having to load the gun. This minimal change approach meant that factories could convert from producing T-34-76 to T-34-85 without requiring complete retooling, and production rates actually increased during 1944, even as the transition was occurring, with Soviet factories ultimately producing over 22,000 T-34-85s during 1944-1945. The development of Soviet heavy tanks was also influenced by lessons from the captured Tiger, though Soviet designers were careful to avoid what they perceived as German mistakes. The IS-2 heavy tank, which entered production in 1943-1944, mounted a powerful 122mm gun and had armor protection comparable to or exceeding the Tiger's, but Soviet designers deliberately kept the design simpler than the Tiger by using proven components from existing Soviet heavy tanks, avoiding the kind of sophisticated but fragile systems that plagued the Tiger, and prioritizing reliability and field maintainability over maximum performance. The IS-2's 122mm gun fired a massive 25-kilogram armor-piercing shell that could penetrate any German tank's armor at combat ranges and was devastating against fortifications, giving Soviet forces a weapon capable of defeating Tigers in direct engagements while avoiding the Tiger's operational vulnerabilities. Soviet production of heavy tanks remained relatively limited compared to medium tank production, reflecting a strategic decision that differed fundamentally from German priorities. While Germany increasingly focused on producing heavy tanks like the Tiger and Panther at the expense of medium tank production, the Soviet Union maintained overwhelming production of T-34 medium tanks, while producing enough heavy tanks to provide fire support and breakthrough capability where needed. This mixed production strategy reflected Soviet recognition that wars were won by maintaining numerical superiority through mass production of adequate, medium tanks, rather than by concentrating resources on sophisticated heavy tanks, and Soviet heavy tank battalions were typically organized as independent units attached to armies for specific operations, rather than as the primary armored force. Soviet tactical doctrine evolved in response to experience fighting Tigers and information gained from examining the captured tank, with new tactics emphasizing combined arms operations, concentration of force against German heavy tanks, and exploitation of Tiger vulnerabilities rather than attempting to engage them in frontal assaults. Soviet commanders learned to use artillery and airstrikes to suppress Tigers and disrupt their logistics, to employ mass tank attacks from multiple directions that overwhelmed German ability to engage all threats, to target Tigers with specialized anti-tank units equipped with heavier guns while medium tanks exploited breakthroughs, and to avoid frontal engagements where Tiger armor advantages were greatest in favor of flanking maneuvers where side and rear armor was vulnerable. The psychological impact on Soviet forces of capturing and examining an intact Tiger was also significant because it demystified the weapon that had terrorized Soviet tank crews since its first appearance. Detailed examination reports were circulated to Soviet tank units explaining the Tiger's capabilities and vulnerabilities, and crews were trained on how to identify Tigers by appearance and sound, how to exploit their weaknesses, and what tactics were most effective against them. Knowing that Tigers had serious mechanical vulnerabilities, required constant fuel resupply, and were immobilized by transmission failures, gave Soviet tank crews confidence that Tigers were not invincible superweapons, but were vulnerable to the same tactical approaches that had proven effective against other German tanks. The broader strategic insight gained from examining the Tiger that Germany was losing despite having better individual weapons because their design philosophy was unsuited for industrial total war, shaped Soviet thinking about military equipment design for decades. Post-war Soviet military equipment consistently emphasized simplicity, reliability, mass producibility, and ease of maintenance over technical sophistication and maximum performance, and this design philosophy characterized everything from tanks to aircraft to small arms. The AK-47 assault rifle, T-54-55 tank series, MiG fighter aircraft, and countless other Soviet weapons reflected the same design priorities that had made the T-34 successful. Good enough performance for the mission, simple enough to mass produce, and robust enough to operate under harsh conditions with minimal maintenance. The Germans, by contrast, never fully learned the lessons that Soviet engineers drew from examining the Tiger, and Germany continued producing increasingly sophisticated and complex tanks throughout the remainder of the war. The Panther, which entered service in 1943, was technically impressive, but suffered from the same fundamental flaws as the Tiger: complex, expensive, difficult to maintain, and never produced in sufficient quantities to affect the strategic balance. The Tiger II, introduced in 1944, was even more extreme with 150 mm of frontal armor and an even more powerful gun, but it was also even heavier, even more complex, even less reliable, and produced in even smaller numbers. Germany's persistent focus on technical sophistication rather than operational practicality reflected an inability to recognize that the nature of warfare had changed and that pursuing maximum individual weapon performance was counterproductive when the enemy could produce overwhelming numbers of adequate weapons. By the time Germany surrendered in May 1945, Soviet forces had destroyed or captured hundreds of Tigers, Panthers, and other German heavy tanks. But the strategic impact of these formidable weapons had been negligible, because Germany couldn't produce enough of them to offset Soviet numerical superiority, couldn't keep them operational due to mechanical unreliability and maintenance requirements, and couldn't sustain the logistical support they required. The captured Tiger, examined in early 1943, had provided Soviet engineers with early insight into the fundamental flaws in German armored warfare philosophy, and Soviet decisions based on that examination to upgun the T-34 rather than design a Soviet super-heavy tank, to maintain mass production of medium tanks rather than concentrating on heavy tanks, and to emphasize reliability and maintainability over maximum performance, proved strategically sound as the war progressed. The story of Soviet engineers examining a captured German Tiger tank and realizing why Germany was losing despite having better weapons is ultimately a story about the paradox of excellence in industrial warfare, how pursuing maximum individual performance can become counterproductive when it compromises the larger strategic requirements of sustained operations, about how technical sophistication can create vulnerabilities that negate tactical advantages, and about how design philosophy reflects deeper assumptions about warfare that determine success or failure at the strategic level. The Tiger was, by almost any measurable standard, a better tank than the T-34 in direct combat. It had thicker armor that provided superior protection, a more powerful gun with longer effective range, better optics that allowed more accurate fire, more comfortable crew accommodations that reduced fatigue, and more sophisticated systems that provided better performance under ideal conditions. In a one-on-one duel under controlled conditions, a Tiger would almost always defeat a T-34, and German Tiger crews achieved impressive kill ratios against Soviet armor throughout the war. But warfare isn't conducted under controlled conditions with one-on-one duels, and victory doesn't go to the side with better individual weapons, but rather to the side that can sustain operations, replace losses, and maintain offensive momentum despite setbacks. The fundamental insight that Soviet engineers reached was that the Tiger's technical superiority was overwhelmed by its operational, industrial, and logistical disadvantages in the context of total war on the Eastern Front. The massive resources required to produce one Tiger, 300,000 man-hours of labor, specialized materials, precision manufacturing equipment, and skilled workers, could have produced many simpler tanks that, while individually inferior, would collectively be more valuable because they could be deployed in overwhelming numbers, because they would be more reliable under harsh conditions, because they could be maintained in the field without specialized equipment, and because they could sustain longer operations due to lower fuel consumption and simpler logistics. Germany's decision to invest limited industrial capacity in producing sophisticated Tigers rather than larger numbers of simpler tanks was a strategic error that actually accelerated defeat by prioritizing individual weapon excellence over collective force adequacy. The Soviet alternative philosophy of pursuing good enough rather than the best proved superior in the specific context of industrial total war, where victory depended on sustaining high loss rates while maintaining offensive operations, on replacing destroyed equipment faster than the enemy could destroy it, on keeping simple but adequate weapons operational under conditions that disabled sophisticated equipment, and on concentrating resources on mass production rather than dispersing them across small batch production of multiple specialized designs. The T-34 was objectively inferior to the Tiger in almost every category of direct combat performance, but it was superior in the categories that actually mattered for winning the war. It could be produced in massive quantities using available industrial infrastructure. It could be operated and maintained by minimally trained personnel. It could sustain operations under harsh conditions that disabled Tigers, and it provided adequate combat effectiveness at a fraction of the resource investment required for Tigers. The captured Tiger that Soviet engineers examined in January 1943 became a symbol of German technological prowess and a stark illustration of how technical excellence can be strategically counterproductive, and the insights gained from that examination influenced Soviet military equipment design for generations. The fundamental lesson was that in industrial warfare, adequacy at scale defeats excellence in scarcity, that simplicity and reliability matter more than sophistication and maximum performance, and that design philosophy must be aligned with strategic requirements rather than with engineering ideals. Germany lost the war of armored warfare, not because German engineers lacked skill or because German tanks lacked capability, but because German design philosophy pursued the wrong objectives, given the strategic requirements of total war against an enemy with superior industrial capacity. The Tiger tank remains one of the most famous armored vehicles in military history, celebrated for its impressive technical characteristics and feared reputation. But its historical significance lies less in its battlefield achievements than in what it represents about the limits of technical sophistication as a route to military victory. The Soviet engineers who examined the captured Tiger in 1943 understood something that German engineers apparently did not: that winning wars requires not the best weapons, but adequate weapons in overwhelming numbers, and that every resource invested in pursuing excellence is a resource not invested in achieving adequacy at scale. The Tiger was a magnificent machine that nonetheless represented a strategic dead end, a triumph of engineering that contributed to Germany's defeat, and a powerful illustration of how excellence can paradoxically lead to failure when it's pursued without consideration for the larger strategic context in which weapons must operate.